Good morning, everybody. Welcome to this What's New in CCP4 session for the study weekend 2019. So we'll have 4 talks in this session. First, I'll give you a general overview of what's new in CCP4. Then I talk about the CCP4 Cloud, which is a cloud computing platform for CCP4. And then Luis Fuentes Montero gives a talk on DUI, which is the graphical user interface for dials. And finally, Rob Nichols will tell us what's new in refinement with CCP4. A new feature in this study weekend is the MR Clinic, where the users with challenging data can get advice and help from the authors of several molecular replacement programs and pipelines. So that will start at 1:30. So you'll have 45 minutes time to have lunch before that. And tomorrow we'll have a number of Lunchtime Bites, which are short tutorial sessions given by developers of individual software packages and other services. So these are split into 11 rooms. You just pick whichever topic you find most interesting. There's some more information on these in your packs. So the current release of CCP4 is 7.0, codename cockerel, which was released 3 years ago. There have been 67 updates since then, so it's about 2 updates every month on average. The latest update is 67, which includes the new select-C binary. So you will definitely need this update if you run anything that requires select-C. So the latest additions to the suite are Fragon, which is a molecular replacement pipeline. There's a Lunchtime Bite in Fragon tomorrow. And DUI is new, fairly new, and there's a talk on that next after me. And more probity is a validation tool from the Richardson Laboratory from Duke University, and it's now also distributed with CCP4. Coming soon is the 7.1 release, coming probably this year, and CCP4 Cloud will be released soon as well. And CCP4 Online is a web portal for running several automated pipelines included in CCP4. You can upload your data and run these programs remotely in the CCP4 Cloud cluster. So that gives you some more computing power than you might have locally. And the latest addition to this portal is SIMBAT, which is a sequence-independent molecular replacement pipeline. There's a talk on SIMBAT this afternoon by Adam Simpkin. And CCP4 organizes every year a number of schools and workshops. There have been workshops on most continents in the world. There's always, you can find information on these on our website. And the next workshop will be in Bangkok, Thailand. The registration is closed for that, but there's plenty of time to register for the other workshops this year. For example, the APS workshop in June. As a new feature, there's a one-day workshop at the ECM meeting in August. This is a one-day workshop, kind of a new kind of short and sweet one-day CCP4 workshop. So check it out from the website. And there's also the CCP Spring Symposium in April. That's a kind of a study weekend for cryo-electron microscopy. There's more information on this in a poster outside. And registration for this is open as well. And more information, as always, is available on the CCP4 Bulletin board mailing list, which is the best place to ask any scientific or technical questions related to crystallography, whereas the CCP4 help desk is the best place to report any problems you might have in running CCP4 software or installing it or running the updates or whatever. And there's the CCP4 wiki, and CCP4 i2 has an extensive documentation and tutorials as well. CCP4 webpage will get a new look in near future as well. And we have a Twitter account, CCP4_MX. So if you use Twitter, you can follow us there for the latest news and gossip and whatever. And so this is a collaborative computational project. So many people have contributed to it over the years, and it has worked quite well. It all started in 1979, which is 40 years ago. And even though most of the software had been replaced, there are still some of the people are still around who were also there at the beginning. So they are still contributing and leading by example. And we are even recruiting new people. So an exciting new opportunity is open to work in the core group at the Rutherford Appleton Laboratory. So we are looking for highly motivated and talented people with software skills and background in crystallography. And so there's a web link here which you can also find on the Twitter page, and it will also appear on our website. So if you are interested in this, talk to Eugene Crisino at the meeting. That concludes the first part. Any questions on that? No, so let's move on. I need to swap. Yeah, CCP4 Cloud is a platform for running CCP4 remotely in the cloud, as it were, instead of running it locally on your PC. So why do we want to provide such a new interface? So there are a number of motivations behind this. First of all, the computational crystallography has progressed quite a lot in in the recent decade, and one trend has been that there have been several new methods which make the structured solution easier because they are fully or half automated, and the user needs to interfere less than before. But these new methods are quite resource hungry, require quite a lot of computing power, and also maintenance of databases and third-party software. So they are more difficult to run locally with limited computing power or manpower for maintenance. Another kind of motivation is, of course, this recent trend of cloud computing or online computing. Many computing functions or features are provided as services remotely through the internet. So we wanted to make several services. This is actually a service-based approach. So for various aspects of computing, like data storage, software, or computations, numerical computations, but it hasn't been applied in crystallography so far. So there are, of course, a number of challenges, such as the data security and bandwidth limitations, but these are usually solvable technically. So we wanted to see if this approach gives something new to computational crystallography. And it would be, the idea is that the users could run CCP4 from whichever device they have, from their tablets or smartphones, just like normally on a desktop or laptop. And one benefit of this would be that the users would have access to the same version of CCP4 wherever they are, both at the local labs and the data producing facility. And not only the same version of CCP4, but also same version of data. And third kind of motivation is the maintenance burden. So we provide CCP4 for 3 different operating systems, and for Linux and Windows we also have 2 different versions, 64-bit and 32-bit. And building and packaging and testing CCP4 for these all these versions is quite laborious. So this is a benefit for the CCP4 team, but also for the user. It would there are even if the installation and update in CCP4 have been automated quite a lot, there are still issues in the individual cases, and we frequently get some feedback on these on the CCP4 help desk. So if we could provide CCP4 in the cloud, so to say, everybody would have, or at least those people who use that version of CCP4, they would have the same CCP4, and maintenance of that would be easier. And another benefit of this would be that the cloud, CCP4 Cloud relies on standard technologies which are also supported by many vendors. So there's high incentive that these technologies will stick around for a long time in the future. So CCP architecture of CCP4, it's a constellation of servers. There is a front-end server which is run on the server or locally, and there are a number of servers on computational servers. And also the CCP4 Cloud takes care of the transfer of data from data producing facilities or from the local data storage on the user's PC. But the users can access this in the front end using any device they have, using the web browser. So for the users, this CCP4 Cloud looks like an ordinary web application, but they have access to computing power through the so-called number crunchers, which can be clusters or individual workstations. You can also include a server locally on the PC where you access CCP4 Cloud. This is useful for interacting with some components of CCP4, such as Coot. And this is completely scalable solution because the number of number crunchers is basically not limited in any way. So it's suitable for crowd resourcing. And yeah. But you can also install this locally on your PC, and then it will work as an alternative interface to CCP4, like the desktop, as an alternative to CCP4 i2. So the first thing the user sees is the login screen. So you can create an account in CCP4 Cloud and then log in using your login name and password. And the first thing after that is you see a list of projects. And you can open an old project or create a new one on the screen. And the projects are presented as a recursive tree-like structure, like a file directory similar to that. And the benefit of this kind of presentation is that it's easy to track down the pathway to the best results. So if you can run you can try various tools in CCP4 with your data, and you can track down the pathway that led to the best results easily using this structure. So you get so each node in this tree is a job. So if you click that node, you get a output report for that job with some nice graphs and reports. And there are several buttons to display the output data produced by the job. For example, there's ugly-mol will show the structure, the molecular structure and the electron density. It looks like Coot, but it's not. It's called ugly-mol. So this runs in your browser. So currently the structure solution pathway is split into 9 principal stages, starting from data import and ending in analysis and validate. That includes also preparation for deposition. And the data import is the first step. So you can upload data from your local disk or from a virtual folder like Dropbox. Or alternatively, data can be obtained directly from the data producing facilities such as the synchrotron. Currently, this feature is limited to iGET storage at Diamond. So that's a proof of principle for that feature. But once the data has been imported, the user no longer deals with the file. So the data object is not equivalent to the file. So file is converted to the object, but the object can include data from several files. And in addition, it includes all metadata related to the job that has produced. Oh, well, later, yeah, I'll talk about that later. There are different kinds of data objects, like unmerged or merged reflection data, or sequence data, or coordinate ensembles for molecular replacement, or the structure including the coordinates and phases, or ligand descriptions. Each data type has a unique name. It has a serial number, which is the job number, and inside job there's a serial number. So each job can produce several versions of the data. There's a human readable name, and also the type of the data is included in the name. So this makes it easily identifiable when you choose the input data for each job. So each job, this is a data, actually the CCP4 Cloud is a data-driven application. Each job, this directory, the recursive project directory shows the data flow from one job to another, down the hierarchy, project hierarchy. And each job creates a new revision of the data object it received from the previous job. And some job can generate several revisions. So that's why the name includes a serial number. So the project can branch at any point. So you can run the same job with several input parameters, or try different tools for the same task, and each of these create a new branch in this tree, job tree. One feature of the data object is that each job will see only the data from the jobs that that are on higher level in the tree. They don't see data from the sibling branches or from jobs that are lower in the tree or lower level in the tree. This has the benefit that it will be much easier to choose the input data for each job, which is beneficial if there are many dozens of jobs in the project. But in some cases, you need to merge data from different branches or move one job to a higher level. But this is rarely the case. So when you want to run a new job, you click the node in the tree and press the plus button. It will give you a list of suggested jobs which you could run using the output data from the previous job. But if the desired job is not included in this suggested list, then you can go to the full list and choose the job from there. What time is it? Yeah, it can happen that the job is framed, has a red frame. This means that job cannot be run with that data. But you can still click it and then you get some advice on why it cannot be run. For example, in this case, refmac cannot be run because the data object doesn't include the phases. So it advises you to run something that, like molrep, that generates the phases. If the job can be run, you get the dialog where you can choose the input data and give the input parameters. And then you just press the run button. And after that, you can just go away. You can log out if you want, and it will run in the background in one of the number crunchers. And when you come back, you will see the result. So currently, the CCP4 Cloud includes several tools for these 9 principal stages. It includes, for example, molecular replacement programs, phaser, molrep, and also automated pipelines, PowerBase, Morda, Mr. Pump, and Simbad. So there are manual kind of non-automated programs and automated programs are included. You can run, you can do model building using the automated pipeline Buccaneer, or you can do the model building manually using Coot, which will run locally on your PC. There's a mechanism for the CCP4 Online to launch Coot locally and access data produced by Coot. All the CCP4 automated pipelines are included in CCP4 Cloud, except Ample at the moment. And in addition, there's also the CCP4 Go, which is an experimental pipeline, fully automated pipeline, which will run several automated pipelines, such as PowerBase or Mr. Bump, and then the automated model building with Buccaneer. So it tries to do the whole process of structure solution automatically. So you can try this first. It might work in at least in easy cases. So currently it's in pre-release state, but you can access it on this website. There is a link on this website where you for advice how to install it locally as well. So one of the design ideas of CCP4 Cloud is to keep it simple and intuitive to use. So if that's not the case, we'd like to get feedback on that. So test users and feedback are always welcome. Yeah, so the acknowledgements, obviously using Crystal is the main developer of CCP4 Cloud, and several other people have contributed to the development as well. And it has been supported by the PBS RC grant. Yeah, so thank you. Any questions? Right.
So, obviously, if you're shifting a lot of the resources onto your own servers and away from the servers that we have locally in the departments,
you can install it locally using your own
but if we all
hardware.
choose to use the cloud system, does there need to be a subscription service in order for you guys to maintain enough equipment to run all of the jobs that would necessarily get transferred? Because at the moment, if we buy more computing power, it comes from our own resource. But if we shift to using the cloud, then you guys are going to have to increase...
No, the idea is that you can install it and use your own hardware, but then many people can access it more easily. The same version of CCP4, so...
Yeah, exactly. I mean, certainly for the Rosetta and Robetta third-party softwares, I can see the advantage of using the cloud system. I'm just thinking, in most cloud systems, you get, say, 10 gigabytes free, and then if you want more space and compute power, you have to pay for it in a subscription service. Is that something that you might consider doing for this to increase, and then we can cost it on our grants?
There are no plans for that yet, but we have the CCP4 online portal, which gives some capacity, but that's only for a subset of CCP4, whereas this CCP4 Cloud can be run with many more tools, but we don't currently plan to make this. You can try it on this website, but there's not a lot of computing power behind that yet. So that's still open. Any others? No. All right, that's it. Thank you.